finally, welcome to the third part of this lecture. Now we have gone through the general structure of the atmosphere, some important trace gases which causes air pollution, and how to measure atmospheric composition on the ground. We have gone through the entire retrieval process of using remote sensing data and converting that into a trace gas product. In this final part, we are going through some of the satellites which are generally used for remote sensing of trace gas concentrations. And we're also going through some applications where these atmospheric remote sensing products have been used. And finally, once all these things are done, we are going through the exercise, which you are going to do later this week as well. So here you can see some of the most common satellites and satellite sensors used for remote sensing of trace gas concentrations. And yeah, I'm not going through them in detail, of course, but what you generally can see is that the older the sensor, the higher the larger spatial extent of the pixel sizes. So the further down here we come, the higher the spatial resolution of the sensors, where then, of course, Sentinel-4.5, just launched now a couple of years ago, has the highest and best spatial resolution of them all, and also hourly coverage, whereas these early ones only had a 3-day coverage, for example. And later on this week, you're going to do an exercise, and what you will be used then is this data from this awesome monitoring instrument launched in 2004. So we will use the nitrogen dioxide data from this sensor here. So now we come to some examples of where these trace gas products can be used for in applications. And here, for example, we have a product of carbon monoxide. And you can clearly see here in China that there is very high concentrations in carbon monoxide in these regions, where we also have a high population density. So we can use this product to see how much carbon monoxide the humans are emitting up to the atmosphere here. And carbon monoxide is also a relatively long-lived trace gas. So we can also use carbon monoxide products to see where do these emitting pollutants, where do they go once they have ended up in the atmosphere. So you can see here that the air pollution that China is emitting, it's blowing up here and then going into the Pacific, for example. Carbon monoxide is also a very important component when burning biomass. So what one can do with this product is to use it to actually locate where do we have a forest fire occurring at this moment, for example. So this is an example of a forest fire in Colorado in 2004. And you can see here, oh, sorry, 2002. And then you can see here that, okay, here's the fire, and here is where all this carbon monoxide, all the smoke is going, where it's blowing away from this forest fire. So these were some examples of how a product of carbon monoxide can be used. Another example of a satellite-based product is this product of sulfur dioxide. And sulfur dioxide, as mentioned in the first part of these lectures, is often emitted from volcanoes. So here we can see how much sulfur dioxide that is emitted from different volcanoes, as an example here from Ecuador and Peru. However, sulfur dioxide is not only emitted by volcanoes, it's also emitted by by humans when burning fossil fuel, for example. And here you can see that there are high concentrations of sulfur dioxide, since there are some volcanoes in the vicinity. Same thing here. There is also a high concentration of sulfur dioxide in the vicinity of this volcano. Here, on the other hand, there is suddenly also a high concentration of sulfur dioxide, but there we don't have any volcano. But there is a copper mine in this location. So therefore, we can use this product to see, okay, here we have a large source of SO2 to the atmosphere that is caused by anthropogenic emissions. Such sulfur dioxide products is not only used for, in relation to this volcanic eruption, one can use these sulfur dioxide products to reroute the airlines, for example. Here we have an example of when there was a volcanic eruption on Montserrat in 2006. And Montserrat is actually located over here. But you can see that these plumes, they have been blowing away with the wind. So when if one would only go for the location of the volcano, maybe the airplanes would avoid this part here. But as you can see, a lot of the actual emitted sulfur dioxide from the volcano is blown away like this, and therefore one should, when routing the airplanes, one should avoid this area rather than this area. Next, we have come to satellite products of greenhouse gases. And these products are, of course, increasingly important for us when trying to monitor climate change. Generally, when we are trying to predict impact of climate change on the vegetation, we are either using models which are just purely run by climate data, but we can also use inversion models where we put in these carbon dioxide concentrations into the model and try to improve our predictions of how much carbon dioxide that is absorbed by the terrestrial vegetation and so forth. So these products, they are increasingly important for our predictions of how climate change is occurring across Earth. And here you have an example of carbon dioxide in the concentration across North America, and a comparison with some different type of biomes. And you can clearly see that the concentrations of carbon dioxide is very dependent on the amount of vegetation that is on the ground. Here we have huge boreal forests absorbing a lot of carbon dioxide from the atmosphere, lowering the concentrations. Whereas here in the southwestern part of US, there is more desert-like and prairie-like biomes that is not absorbing as heavily, and thereby the concentrations in the atmosphere is actually a little bit higher. Next, here we have an example of a product of methane across the Earth, and you can clearly see that there are very high concentrations in India and in China, where we are producing a lot of rice. So this is causing a lot of methane emissions here. Yes. Finally, we have come to an example of the product of nitrogen dioxide. And this image here is based on nitrogen dioxide from the ozone monitoring instrument. And this data is produced using exactly the same methodology which I described for you during the second part of the lecture here. And it's also those data that you will work with during the exercise later this week. And when working with this data, like mentioned before, you should use some monthly average product, since there are some errors left when having just the daily product. So in order to make it as reliable as possible, we should take some sort of average estimate of a longer period, such as, for example, a month. But when doing this, some clear spatial patterns can be seen. And this is obvious here that we have high concentrations in the most densely populated parts of the world, and also in the most industrialized parts of the world. So it's very obvious here that the higher the population and the more we humans emit to the atmosphere, the higher the concentration of the atmospheric air pollution is. And we actually live in the part of the world with the highest air pollution concentration of all. But it's not only humans. You can also see some minor higher values in other parts of the world. And here in Africa, for example, and South America. And this is caused by when lightning is striking, then some nitrogen dioxide can be produced in this high energetic process that is occurring when the lightning strikes. And also when biomass is burned, then some nitrogen dioxide is produced. So this is the reason for the high values here in Africa and South America, whereas these extremely large areas with high concentration is caused by us humans emitting nitrogen dioxide to the atmosphere.